This is a test to show that the Arduino board has been detected. It says that it's been detected down here. If I close the program, connect the Arduino, and load the program back up. Let me just readjust the size of this. It says that no Arduino has been found. Test successful. Next, I'm going to test the tabs in the function. Once I click on a tab, it shows a tab. I write hi and hello in the tabs, and when I switch between them, they change, which means the tabs work. I can switch between them both. I'm going to save the program, even though it's not a proper program. I'm going to save it, and the dialog comes up. Press save. Let me show you. Save. Then I'm going to delete the text to show you that it does actually load up. Click load. Find the file. Saved it underneath text, or test even, and it loads up. It also says at the I'm going to make a new project, and it says at the bottom, new project created. This test I'm going to show you that the user has to be on the right tab to assemble their finished program. If you're on the assembly code tab, it should compile. But if I compile it on the machine code tab, it doesn't compile, an error pops up. Once I switch tabs, however, it should compile. Click on the tab. Yeah, it compiles. For the next test, I'm going to make a program that branches. This program will also include an immediate reference. Okay. Let me just write this. This is the label identifier, so this is where it's going to branch to. That's the immediate reference, so that's the actual value 1 and not the register value 1. And this is the branch instruction, and here is the label to go to. That underscore means that it's a label address. Once it compiles, you can see when it's assembled, the add instruction is there, and the branch instruction is here, and the label has been found and entered into the branch instructions parameter. The immediate address table has been spotted. Immediate address has been spotted and put into the immediate address table at the bottom of the program, and the argument in the instruction itself has been referenced to the table. Okay. This means that it's fully worked. Yeah. That value there and this value here. Next, this shows that the user can enter any gobble and the program will still not crash. See, all these errors popped up. That's proof that it works. Next test, I'll show that if the wrong mnemonic is entered, the relevant error pops up. So this is a mnemonic which I don't cater for, and it says abstract mnemonic, which means that there is no mnemonic. Next test shows if the user enters a register or references a register which is higher than the amount of registers that we have in the system, it shows an error. So R15 is not in. We don't have a register 15. And sure enough, it says the error corresponding Next test shows that if the user enters too many arguments into an instruction, an error pops up. Yep. The same is tested but with too little arguments. The same error pops up, but for the opposite. This test shows that if the parameters are entered in wrong fashion, it will show an error. In this case, I'm entering them without any commas. An error shows, even though it's not representative of the problem. This is what's supposed to happen anyway. This test shows that if a label identifier cannot be found, then an error will pop up because there is nothing to branch to. Yes, it does. Right there. Oh, getting corrected by my own program. Anyway, shows it there. This test shows that if you reassemble, it doesn't append to your previously assembled program. So if I go back to it, it's there still.